evening. Welcome to today's presentation, Securing Access in Cloud Environments with Saviynt and Chef. Let's go ahead and get started. Vibhuti, why don't you kick us off by telling us what we're going to be covering here today?
Thank you very much, April. Good morning and good afternoon, everyone. Thank you for joining me and Nick on this webinar. For today's agenda, we have some interesting topics where I'll be talking about the cloud infrastructure as a service security overview and how you can manage privileged access management using Saviynt and Chef. Then we'll have Nick talk about how Chef can be used to do a continuous automation using the Chef's Inspect and Chef Automate technology. And then we also have lined up two set of demos, one for the Saviynt privileged access management solution, and the other one which Nick would be doing in around cloud compliance with Chef Automate. And then we'll keep around 5 to 10 minutes in the last for audience Q&A. So without further delays, let's get started. If I break the problem of securing access to any cloud infrastructure as a service, it comprises of three key parts. One being getting or discovering the security misconfigurations, access violations, and then mapping them to industry standard compliance frameworks, namely CIS, SOC 2 Type 2, NIST 853, etc. Another interesting aspect on that would be like once organizations achieve compliance, then how do they stay compliant in a continuous manner? So we'll give you a primer about what we are learning in the industry, how we are helping our customers to address the first pillar as we describe it as visibility, compliance, and prevention. The second very important aspect in securing infrastructure as a service is to manage privileged access to your cloud infrastructures like AWS, Azure, Google Cloud, etc. Privileged access on an infrastructure service can be gained via various conduits. You can gain privileged access by going to your management consoles, your APIs, your CLIs, your end workloads like EC2s, your RDS databases, or even serverless technologies like Lambda functions and Azure functions. The last part here talks about identity governance and administration. And for today's webinar, we are going to skip this part. There's an additional and upcoming webinar, and I would urge all of you to register for that too. But in today's webinar, we are going to focus only on the first and second legs. So let's talk about the first pillar, which is how do you gain visibility and how do you map that to your compliance framework. Gaining visibility requires continuous monitoring of your cloud environments against a predefined set of risk and security controls to detect vulnerabilities. Discovering insecure workloads and tying it further to understand who has access to those workloads and what are they really doing with that access is extremely important. However, what is more important is that once you get that visibility, once you understand what your vulnerabilities and misconfigurations are, it is further important for a solution or for a product to allow you to take action on those visibility or visible configurations. So thereby, when you are looking for a solution or when you are trying to design a solution to gain visibility, do not just look for something which can give you a dead report, but look for controls which are actionable in nature. And the more important aspect of this would be that once you have discovered your insecure configuration, mapping them in terms of your industry standard compliance frameworks is the next logical thing to do. And again, organizations are struggling in order to understand where the delineation of their responsibilities reside. Organizations like Amazon and Microsoft have spent enough time and effort in explaining the whole idea of shared responsibility model, but organizations still struggle to understand where their responsibilities lie when it comes to securing their workloads, especially when it comes to infrastructure as a service. So thereby, our recommendation would be to always look for a third-party solution or get some external help when you are trying to map your audit and compliance needs when it comes to securing your cloud ecosystem. Now, moving on to the next part, which is privileged access management solutions. So Nick, would you like to share your views and why exactly privileged access management solutions are needed, and the strong need what you are seeing with respect to your customer implementation. Go ahead, Nick.
Absolutely. And a big part of this, right, is being able to centralize control of environmental access. And particularly in my past life as a systems administrator in a time before configuration management tools, this was always one of the biggest problems we faced. If we had new users being onboarded or employees leaving that needed to have access revoked from systems, without a centralized way to control essentially our master ACL, we had to go sort of machine by machine, treating each server like our manually curated pets, and ultimately made it very hard to audit where we had access grants. Because again, we had to reach out to each system individually and assess whether or not the folks that belonged there were there and the folks that didn't belong there weren't there. And ultimately it all comes down to, we're looking to increase our security and decrease our risk. And by centralizing the information we have about where access has or has not been granted, we have both improved visibility into the security of our systems and a better way to enforce our security standards.
Thank you, Nick. Great points, Nick. And to add to what you just said, the whole exposure and the risk on your cloud ecosystem is extremely high. So thereby, understanding the real challenges of privileged access management becomes imperative before you even think about designing and implementing a privileged access management solution for your cloud ecosystem. So let's take some time to understand what those challenges are when you think about designing and defining your cloud PAM solutions. But before that, I wanted to have a quick poll for everyone to understand that how many of you are trying to use an enterprise-focused PAM product to solve your PAM needs for the cloud IaaS? The results would be published once you all submit your answers. So please go ahead and provide your answers here. All right, and I'll go ahead and wonderful. So it becomes very evident that none of our audience here is trying to use an enterprise-focused PAM product to use or solve their cloud PAM needs, which is the whole essence of driving this webinar. So let's understand what the traditional challenges in cloud are with respect to PAM. So the first one, which I would like to explain a little, is that the traditional PAM products, they rely on a proxy or a gateway-based solution. And often what it does is it becomes a choking point in your architecture, and it is not able to handle the scale and the agility which is often needed in an ephemeral environment like cloud. The second one, which is pretty obvious, is that the whole idea about bootstrapping and rolling out your PAM solutions in cloud, it takes a lot of time if you try to retrofit your traditional PAM product and put it on cloud. Nick, would you like to share your views, especially when it comes to bootstrapping and then provisioning and doing the lifecycle management of your service accounts to get your environment ready?
Yeah, and I think a lot of it comes down to, as well, these challenges compound with whatever provisioning mechanisms are in place, where there's certainly a tendency to sort of bake images with kind of base understanding of what's required across an organization, but then sort of dealing with per environment or per role updates can take time to evaluate and bootstrap. So often you'll sort of see, tools like Integrated PAM or Chef Client kind of taking the role of having each individual managed machine be able to pull its required config automatically. So it removes a human step from that bootstrap process.
And great point, Nick, because this is what makes the traditional PAM product having a big reliance on additional integration with identity governance and administration products to handle that lifecycle management. And this dependency really just extrapolates, just creates a long pole in your overall implementation of the PAM solution. So again, products like Chef is key when it comes to lowering down your bootstrapping time. And we are going to talk about how and what Saviynt and Chef are doing together and trying to disrupt this particular space. One other key thing, which is the absence of governance and risk awareness in the entire PAM processes. It's a big issue when it comes to privileged access management, because you will have to again rely on homegrown solutions or some third-party products to provide governance, as in who is doing what, how did your request got approved, when was it approved, and under what context it got approved. So having that information about the context, bringing governance into the fold when you are implementing or designing your PAM solution becomes imperative. And again, we are going to show you that as part of the demo, that how we are bringing in not only governance, but also the factor of risk in your overall processes, which again will take care of some of the processes, like if someone is requesting for a very critical or a very sensitive privileged workload, then the element of risk will allow you to have or bring in more additional security controls on top of it, like stepping up the authentication, going for additional proofing, etc., etc. So with that being said, let's take another poll question where what we wanted to understand is that is your current PAM product or solution, it is struggling to meet the scaling needs of your cloud infrastructure as a service. So the question is here on your screen. Please go ahead and submit your answers, and we are going to publish it very shortly. All right. Since we didn't get any answers, so we'll skip that, and then let's move on. So now, since we understand what the challenges are, what we realized is that before we start designing a PAM solution for cloud, we have to define what our fundamental pillars are. And the 4 cornerstones in Savynt's PAM solution are, number 1, we internally use HashiCorp's Credential Vault. HashiCorp is an undisputed leader when it comes to vaulting technologies, and we chose HashiCorp because we needed to provide the agility and scale which a cloud system needs, and obviously that they became our obvious choice. The second one, when it comes to automating your DevOps processes, and again, as Nick mentioned earlier, that the whole idea of bootstrapping, when you think about solving your PAM needs, is very key, especially in terms of how quickly you want to roll out your solution. So Chef is the right choice, or Chef was the right choice, because that it brings the scale which is needed for your infrastructure and still achieves or still manages to give you consistent results. The next cornerstone in our architecture solution was to use Elastic for any kind of audit vaulting and analytics engine. Again, because of the sheer technology with which it can handle the velocity and volume with which audit logs get generated in a cloud ecosystem, Elastic became an obvious choice. And lastly, as I mentioned earlier, a jump box or a gateway-based architecture doesn't go well in a fast-moving, transient environment like cloud. Thereby, what we decided and what we came up with was there has to be a web-based, lightweight, containerized SSH solution which can meet the needs, which can be fast, which can be agile, which can be scalable and quick to launch and handle the needs for a cloud ecosystem. So again, with these 4 cornerstones, and if I look at all the challenges, the key design principles to build a cloud PAM solution would be, number 1, the access elevation should be temporal in nature. The solution should not have to create separate privileged IDs for your users, because again, it creates more issues in your user lifecycle management. Number 2, the concept of auto-registration and workload discovery becomes extremely important in cloud. Traditional PAM products, they rely on recon-based methodologies wherein a workload gets added, and then whenever the next recon happens, that workload becomes available. That doesn't go well with cloud. You need to have something which can be auto-registered, the workload should be bootstrapped, and ready to go in real time. Number third is the entire idea about SSH key distribution and credential vaulting. Traditional PAM products do not do your SSH keys creation. They only take the keys when they are provisioned and push it onto their vault. Whereas if you're talking about a seamless experience for a cloud PAM solution, the entire lifecycle management of SSH keys need to be wrapped up in a turnkey solution which is needed. Very, very important is that the entire service account lifecycle management should be integrated. Going back to Nick's point, investing in solutions like Chef, which can help you in doing a faster bootstrapping and helping you to manage your lifecycle of your service account is the key to achieve and design a proper PAM solution. And lastly, built-in governance and risk-aware processes are key. For example, if someone accessed a workload and it allows organizations then to determine who approved that request, what was done with that access, and further, who else has that type of access. And to augment it further, adding risk in the overall flow becomes important because adding the context of users, the type of workload being accessed, the time of access, and several other parameters help the system to gauge a risk score based on which additional controls like step-up authentication, additional proofing, etc. can be fired. So to sum it up, a PAM solution, what we are trying to come up with is, which is not based on a jump box model, does not have a thick SSH or an RDP client, completely web-based, and no separate reliance on an IGA product. The convergence of an IGA product and to a PAM product into one, which can be delivered from cloud, is the answer to solve all your cloud PAM needs as we move forward. So with that, I'll hand it over to Nick to explain his part of the story here. Nick, over to you.
Yeah, and I think sort of really the key theme here is that as we move our workloads into the cloud, we're doing it in the service of being able to increase the velocity with which we are able to adapt to our customers' needs, being able to have the right amount of infrastructure and the right cadence of change to make sure I'm providing value to the folks that depend on the things I create. And so ultimately, what drives that velocity are being able to increase the speed of change and the efficiency of making those changes, so we spend less time reworking mistakes, all without increasing risk. Because if we are simply driving toward a metric of increased speed, we have the potential to severely impact our risk stature. And certainly as we see organizations migrate to the cloud, this is where folks are feeling the most pain. It wasn't very hard when I did some research not too long ago to see, what organizations have seen breaches on something as simple as misconfigured storage or access control policies. And those are all things that are done in service of getting into this flexible and dynamic environment quickly. And so we're going to take a look at how we can achieve that speed without ever losing insight of potential impacts to our security posture. So the driver of this with Chef is a tool called Inspect, which we'll be seeing a lot of today. And I'm curious to see from the audience, how many of you are using Inspect today? And if you are, what the nature of that use is, whether you're validating your infrastructure and or application configurations, or whether you're also validating cloud service configurations, things that aren't traditional servers, but things like storage buckets or key vaults in cloud solutions. So I'll give folks a moment to get answers in, and then we'll dive into the next section. All righty. So let's have a look at the results. So looks like a vast majority said not yet. So hopefully we'll have some compelling arguments for why you should get rolling today. And then for those of you that are using it right now, using it to validate infrastructure and no one yet using it to validate cloud service configurations. So that's great. We'll see some examples of how that can be done today. So ultimately, as I mentioned before, and oh goodness, I need some inspect tests for my PowerPoint fonts. But ultimately, the name of the game here is being able to increase the speed at which we do business, because ultimately that's what drives our ability to deliver to our customers, but without, in turn, decreasing our efficiency by rapidly producing work that needs to be pulled back and redone, or increasing our risk posture. There we go. And ultimately, the means to do this is to have a repeatable process for essentially evaluating all the work we do in 3 steps: detect, correct, and automate. We need a way to rapidly gain visibility into what reality is, where we have security gaps that need to be addressed, and where things are properly configured. And in those cases, have a way to turn those detections into actionable remediations and correct whatever misconfigurations or security flaws, unpatched systems, etc., we uncover. And finally, we need to automate that process so that as we identify and remediate each of those issues, that's work that never needs to be repeated. Anything that we create net new going forward has this as table stakes, because we've automated the process we use to do our initial assessment and remediation. And so ultimately, where Chef Automate and the constituent tools, Chef, Inspect, and Habitat fit into this are providing automation engines to enable this journey. With Inspect, we have the ability to test our systems against industry benchmarks provided in Chef Automate and report any addressable misconfigurations or failures in continuous audits. With Chef and Habitat, we can use that data to inform how we configure systems and applications, and correct with the same tool set we use to identify the gaps in our systems. This allows us to develop baselines for automations across every type of work we do, and make sure that everything we manage is delivered via one of these automation engines, allowing us to solve problems continuously and as we move forward into new environments and designs. Another key thing about using the same tool set for all of these is that it takes business units within your organization that often work in silos and gives them a shared worldview. One of the biggest parts of organizations where we see a lot of work duplicated is in the security and compliance realm, where you have sort of an information security or compliance team that is dealing with a set of concerns based around industry best practices or compliance regimes, that then need to translate those into the actionable work for I&O teams and developers to do and inform their development and maintenance of environments. By being able to translate those compliance concerns into something that takes tangible data from your running environments, we're able to sort of facilitate a direct path from our compliance concerns to the work that our teams need to do to meet them. And one of the ways that Chef Automate helps with this is with a library of pre-built profiles to sort of jumpstart your compliance story. In particular, we ship with CIS, or Center for Internet Security, baselines for a variety of operating systems as well as cloud platforms. So if you're not familiar with CIS, they're a generalized security control system that's recognized by a number of industry standards. So NIST in particular recommends CIS, as do the European Telecommunications and Standards Institute. And CIS also provides mappings for how their controls relate to specific compliance regimens. So if we're talking about something like PCI compliance, HIPAA compliance, et cetera, we can see how those CIS controls map so that we can take these benchmarks and drive them directly to the value they'll bring you in an audit. We also have started shipping DISA STIG benchmarks as well, which are similar benchmarks built for or by the Department of Defense. So you'll see those in anyone that does federal work or Department of Defense contracting. And with that, we're going to show you sort of the solutions that Savyint and Chef provide, starting with the Savyint PAM solutions that Vibhuti was talking about earlier.
Thank you, Nick. And I'll go ahead and share my screen. Nick, are you able to see my screen?
Yes, sir.
Wonderful, wonderful. All right, so now let's talk about how things work. And we have lined up a demo here. What you're seeing on my screen is the Savyint Cloud PAM solution. Very important to understand that Savyint's Cloud PAM expands and cuts across all the cloud computing layers, whether it is for infrastructure as a service like Azure and AWS, or it is for SaaS applications like Office 365, Salesforce, Box of the world. And further, it also extends to some other crown jewel applications like SAP GRC and Oracle ERP platforms as well. But for today's webinar, let's focus on AWS or infrastructure as a service, and I'll walk you through how exactly you can use Savyint's PAM solution to manage privileged access on these platforms. So within AWS, again, as I mentioned, there are different conduits through which you can request for privileged access. You can request for the consoles, the CLIs, the APIs, or even end workloads. And I'll show you each of that one by one. Let's start with the instance access. The first and the foremost thing here in the instance access is all of these instances have been bootstrapped by Chef, and the privileged IDs through which you can request access for are already available in Savyint. Now, when you install or implement Savyint on the very first time, you will be doing a bulk import of these constructs from Chef. But going forward, as and whenever a new workload gets pinned up, those workloads are automatically bootstrapped by Chef, and I'll show you the Chef Automate configuration in a moment. But the idea here is that anytime when a new workload gets created, not only that workload is auto-discovered by Savyint, but it also gets automatically boosted in Chef as part of the cookbook configuration, as well as it becomes ready and available for any end user to start requesting access for. And again, I would like to stress on the fact that this is key for an ephemeral environment like cloud, because the way your scaling up and down works in cloud, until and unless you have an auto-discovery mode enabled, it becomes really frustrating for your end users to request privileged access for your instances. So that being said, so this is my list of instances. You can request for a shared ID. You can request for your own IDs depending on which of them have been tagged as privileged. And you can search for your instances based on the account, AWS accounts, your instance OSs, AWS regions, or also based on tags. So you can search and do a lot based on what kind of tags you have in your environment, and you can use all of that to search for your instances. And again, search becomes extremely important because of the scaling up and down. Your instances will change, and traditional methodologies of searching based on IP addresses do not scale well in cloud. So let's say you want to request for this access, very standard model wherein you can check out your access for this particular session. Now what you see here is a set of important constructs. Number one being the duration of this access. The duration of this access can be defined at multiple levels. The levels could be at a complete AWS region level. It could be even defined at an individual architectural tier level. So for example, you can define a standard duration for all your application servers or all your DB servers. And further, you can also define a time or a duration at an individual workload level. And the least allowed time always takes precedence. So here in this case, I'll just go and submit it. Now, obviously, for demo purposes, we have kept it as in an auto-approved state, but you can define workflows for your very sensitive workloads, which can go up to 1 or 2 level approval. You can define slots depending on wherein if someone has already checked out this particular request, then no one else can request for this particular workload. So all of that exists in the framework. And once this request gets approved, then obviously the next step for you would be to go ahead and manage the session or request for that access. So a couple of things what happened behind the scenes is, at this point of time, the user's SSH keys have been created on the fly, and it has been pushed onto the backend HashiCorp vault for the vault to ensure that it starts managing those credentials. And once that is done, then obviously the user would come in and request for that instance. So here in this case, this particular instance is now ready. You can go ahead and request for this session. And what you would see here is that with that one click, I have opened a complete new browser-based SSH session from your machine to the end host. And there's a lot of magic, I would say, which happened behind the scenes. Number one being the credentials were fetched from HashiCorp Vault. Behind the scenes, there's a Dockerized container which got spinned up in real time, and then SSH tunnel was created between that Docker container and the target host. All seamless to the end users. The end users do not have to worry about keys. The end users do not have to worry about having any thick SSH client or terminals on their laptops. All of this is happening from the browser. The other aspect here is anything which a user types in, whether they are typing in any commands, any false commands, anything which they are typing, everything is getting keystroke logged and being sent to the backend Elastic Vault of Saviynt. So that's on the keystroke logging, and I'll show you in a moment what those logs look like. But the idea here is that anything which you are logging in here, it is getting monitored by the Saviynt spam solution. Other one which is important is the inline session prevention. So let's say you as an organization, you want to define certain policies saying that as a user, even though if you have privileged access on my workloads, there are certain commands which I do not want you to run. For example, I do not want you to be pushing any patches. I do not want you to be changing host file. I do not want you to be doing X set of things. So you can define those policies and you can attach those policies in Saviynt, and those get applied in real time when the users are trying to access these workloads. So with that being said, let's take a look at what the controls were. So for example, all the logs which I'm monitoring right now, all of them, they get captured in real time. And as you can see here, as a user, whatever I'm typing in is being sent here, which can be monitored, which can be reviewed by your compliance officers, by your AWS administrators, by your server admins, to understand what your users are really doing with that access. And an important aspect is, if they are using a shared ID, then their usernames are also being tied to which shared ID they would have used. And more importantly, all of this information is actionable in nature, so you can further, if you find that there is some session which is suspicious, you can go ahead and stop those sessions. You can also disable that user's account on the target workload. And if you need further analysis and look at the raw logs which is getting streamed from those target workloads, you can do that, which is again going back into our Elastic cluster, and this gives you the details about all the information which is needed for a forensics analysis with a specific activity which has been performed in your environment. And having said that, a couple of other things which we do is we also integrate with Chef Automate, as I was mentioning earlier. So this was the instance which we created. And as part of the integration between Saviynt and Chef, to ensure that the necessary attributes, the necessary information gets passed to that instance as part of the bootstrapping process. And all these information about your user accounts, your attributes which are necessary to bootstrap a new workload gets pushed with Chef. So with that, I would wrap up this particular demo. I hope that all of you would find it very, very intriguing. And if you are looking for a cloud PAM solution to manage privileged access for your infrastructure as a service, then please feel free to reach out to me and Saviynt as well as to Chef, and we can help you in doing this. So with that, I'll stop the sharing. Nick, I'll pass it over to you for your piece for the demo.
Thank you, Vibhuti. That was great. So let me get my own screen share set up here. And if I did my job right, folks should be seeing my Chef Automate server. So one of the things I love about that sort of PAM dashboard is that not only does it give you a lot of the things that I was talking about in the Chef Automate overview, tools to both detect and correct deviations from corporate policy or suspicious activity, but it also gives you different levels of insight based on both the very granular command by command level, as well as an aggregated overview of what a particular user or account has been doing. And that's something that becomes very important when we're talking about solving for security issues, where I want to be able to, at a glance, see how my environments as a whole are performing. Now, right now, what we're looking at is Chef Automate's compliance dashboard, where we're seeing a similar view for what's happening when we run compliance audits of the infrastructure I'm managing. Right now, pretty simple setup, just a half dozen or so nodes out in AWS. Now, here I see that of my nodes, they look to all be passing the audits. Right now, I'm running some essentially generic Linux security baseline stuff, making sure that I don't have any insecure packages installed or misconfigured firewalls, things like that. And we can also drill into node by node details. So if I want to see the performance of a particular node in my system and what specific evaluations were made against it, I can see all of that here. Now, of course, when demonstrating a auditing tool, it'll be real boring if everything's just passing all the time. So let me clear my filters here, and we can see some of the other stuff I've been doing in my environment. So I've been running a few extra things here. So now we see a few failures. Right now I have 3 failed audits across my environment. And we can actually see a further breakdown. These lines here show us how many of those are critical or major failures. Essentially, what is the most critical things to be attended to. We can also break that down by the profiles that we ran. And again, seeing a breakdown not only of failures, but of the criticality of those failures. So we can see where we need to focus our effort. When we go into the breakdown, let's see what our actual failing nodes are. And one of the first ones to note is not a server at all, but US East 1, which is a region in AWS. So I mentioned earlier, Inspect has the ability not only to scan infrastructure or applications, but our actual cloud environments themselves to see whether or not all of the entities within my cloud, my access management, my storage buckets, databases, et cetera, are in turn securely configured. And what we're seeing here are actually the CIS benchmarks for AWS that the Center for Internet Security has published. And we can drill down and see, certain things are indeed set up nicely in my account. I have password rotation happening. I don't have access keys for my root account. But when we take a look at some of my failures, well, here's some of the fun of working in my demo accounts. These are sort of log monitoring that it's recommending I have set up, but most of my things are ephemeral and unimportant. And fun things like security groups allowing access over ports that they often shouldn't. And these will be for like my demo and training environments. With each of these as well, though, I can actually drill down and see, for example, when we take a look at ingress over port 3389 here, a security group by security group breakdown. And I can see which ones specifically are misconfigured so that I can address accordingly. Now, that's just the AWS foundations, which you can find in our asset store. Right now, that's the only one I have installed. But if we take a look at things that are available, we can see similar profiles for a variety of operating systems and cloud providers. So there are similar profiles, say, for Azure, as well as things like the STIG profiles I mentioned earlier. Now, my systems are running Ubuntu 16.04, so let's see what we have available to me if I want to take my security evaluations one level further. And I see here that I have a bunch of 16.04 benchmarks for Ubuntu, broken down between server and workstation, and level 1 and level 2. In the CIS benchmarks, the distinguishing feature between level 1 and level 2 are how impactful the controls are. So level 1 controls are generally seen as non-impactful to most running services. So the things that it will flag shouldn't disrupt your systems if implemented. However, level 2 are a little bit more stringent. And those are ones where, when we remediate, we'll want to take care that we're also evaluating whether it negatively impacts the actual services we're providing to our customer base. For me, I'm going to go ahead and grab the level 1 server benchmarks, and I'm going to apply that to a couple of my servers to see how they stack up against it. In scan jobs, we can actually create one-time scans or recurring scans to systems that we can connect to over SSH or WinRM, as well as any cloud environments we have configured. So we see here where I set up that CIS scan of my East region. To create a new job, I'm just going to go ahead and take a look at what nodes I've added. I've added both of my development nodes, and I can select which of my installed profiles I'd like to apply to these. In this case, the CIS benchmarks for Ubuntu. Finally, we'll give it a name, CIS Ubuntu Scan. And that's going to go ahead and run at once. Alternatively, we can give it a schedule if we want this to be a recurring scan that we run every hour, every minute, whatever the cadence would be. And if we need to add any new nodes, we can add those from this view, where I can put IP addresses or host names for any machines I'd like to add, and select any security credentials or login credentials, rather, that I can manage in my settings. And this is where I can do things like configure SSH access and WinRM, where I can set up integrations. So this is where I configured access for AWS, as well as define rules for lifecycle. Since Chef primarily runs on a pull-based model, I might have issues where machines are taken out of commission and aren't checking in. So we can either have that be a manual deletion, so we can separate machines that have an actual issue versus machines that have been retired, or we can create rules for when machines should be marked missing and when and if missing nodes should be removed. But with that, let's see how my scan job did. Looks like the job has completed. And once again, I can see some failures that we can dig into. In this case, again, our controls are broken into the severity, where I can view all of my past controls aggregated and my failures by severity. And because each of these describes precisely how it's being evaluated, these become actionable insights for me. In this case, we're seeing whether or not different file systems are allowed to be mounted. And at this point, I can either determine that this is a rule that I would like to enforce and create the corresponding automation in a tool like Chef to enforce that rule and solve this audit problem, or either because it's not imperative to my business or I have compensating controls in place that mitigate my need for applying any of these, we can also add exceptions in InSpec to skip rules based on whatever criteria we would define as an organization. And that's it for my live demo. And so with remaining time, Vibhuti and I would love to answer some of your questions. And if you haven't seen already, you should have a Q&A widget in the presentation manager that will allow us to ask us any questions that are on your mind. And with that, why don't I grab one off the top of the stack here. And actually, good follow-up to what folks just saw. Are built-in profiles certified by CIS? So CIS has a certification process, and Chef has been in the process of getting our profiles certified. So a number of those right now, particularly the, I believe the Azure, Google Cloud, and Red Hat Enterprise Linux profiles are certified. And you can see the full list as we get new certifications announced, both in our blog and on the CIS vendor partners page. And Vibhuti, it looks like we have a question here about the Savyint PAM portal there. the question is, which cloud providers or access management solutions does Saviynt integrate with?
Yeah, thanks, Nick. So when it comes to cloud providers, as I explained earlier, Saviynt PAM solutions in its first release will be integrated with AWS and Oracle ERP and SAP GRC solutions. In release 2, which is going to be the end of this year, we would further extend the capabilities to Azure and Google Cloud from an infrastructure standpoint. Saviynt PAM also is currently integrated with Salesforce, and with the release 2, which is coming by end of this year, it will be integrated with Workday and Office 365. When it comes to PAM integration with IAM solutions, Saviynt already has a IGA product, and Saviynt is seamlessly integrated with it. Other than that, when it comes to access management or IDaaS solutions, Saviynt PAM also integrates with the Ping, Azure AD, the Okta, and all the other IDaaS providers available in the market.
Oh, helps if I take myself off mute. Thanks, Vibhuti. And I guess that's probably a good point for me to mention as well on the Inspect and Automate side of things. Inspect has the ability to scan APIs of the big 3 cloud providers, AWS, Google Compute, and Azure, and as well as the ability to scan Docker containers. In the Chef Automate dashboard, right now we have built-in integration with Amazon as well as Azure and Google Cloud available behind a beta flag soon to be released in GA. And let's see here. How can Chef Automate help prepare for a compliance audit? So things like HIPAA, PCI, et cetera. So in that case, I mentioned earlier the mappings that can be done from those CIS benchmarks to compliance regimens. Now, when it comes to a formal audit, the scope of what an organization is going to need to do is going to vary from organization to organization, depending on what variety of systems they're maintaining. What the built-in profiles in Automate provide is a way to get a leg up on that. Each of those controls map directly to a concern on various compliance regimen that CIS publishes. And at Chef, we've also published a couple of white papers to help sort of tell this story more specifically. In particular, we have a PCI DSS and FFIEC white paper that talk about mapping both controls that are part of the CIS benchmarks, as well as custom controls that can be written in the Inspect language to start preparing for those respective audit types. There's also a white paper that deals with GDPR regulation in the UK or actually in the EU as far as data privacy law is concerned. And similarly, it goes through the process of mapping specific controls in Inspect to the broader concerns of the compliance regimen. And let's see. Doesn't look like there are any other questions, so we'll be hanging around if folks want to throw some in. But at this point, April, should we let folks know what resources we have available?
Sure. Thanks so much, guys, for that. That was a great presentation. As a reminder, a copy of today's presentation and resources are located in the resource list widget at the bottom of your screen. We encourage you to download the slide deck and bookmark any links you might find useful. We, of course, hope you found value in all of the information presented today. If you like what you saw, we encourage you to share the presentation and with your professional network and teammates. The on-demand version should be available by tomorrow, and we will email you a link to it. You should be able to access it using the same audience link you're using now. Thank you again for your time, guys, and have a great day, everybody.
Thanks, everyone.
Thank you all. Thank you. Bye-bye.